Alright, here we have screencast 8, which is to draw and explain the physical situation that would result in the given equation. And here's the given equation. First, we had to identify the physical principle being used, which is the conservation of energy, which comes out to the change in kinetic equals the minus change in potential. Here's all the knowns that was given to us: the mass, the gravity, moment of inertia of a sphere, velocity final, the kinetic final, which is the 1/2 mv squared, kinetic initial, which is 0 because it is not moving, kinetic final, which is also 0 because the height is 0. It's at the bottom rolling down a hill. That's why the height would be 0. The potential initial is at some height. The rotational kinetic energy is 0 for initial because it's not rotating. And then the kinetic rotational kinetic final, which would be at the bottom of the hill. So once again, this is the given equation we were given at the top. Translating that into the conservation of energy, the kinetic final minus kinetic initial, plus the rotational kinetic final minus the rotational kinetic initial, equals the negative potential final minus potential initial. And subbing in all my knowns into the equation, we have the kinetic final minus the kinetic initial, which is 0, plus my moment of inertia of a sphere times omega squared, which is my rotational kinetic energy final, minus my rotational kinetic energy initial, which is 0, equals the minus potential final, which is 0 at the bottom of the hill because the height is 0, and then minus the potential initial. And once these cancel out, you'll have a positive value, because you should have a positive value, because up top we have a positive value for my kinetic energies. And then basically here's the diagram that I drew that we were asked to draw. Initial setup at some height. Ball is rolling down a hill or an incline. And this is the final position here where the height would be 0. That's why the potential energy is 0. And that is my screencast number 8.